Okay, we have just completed how to find shortest distance between a point and a line. Correct? Shortest distance between a point and a line. 6.3.3, we will deal with finding the shortest distance between a point and a plane. Let's use an example to illustrate the two methods that we're going to use to find the shortest distance between point and plane. Now, example 11.8. Position vector of a point P is 4j, and I have an equation of a plane here. Find the shortest distance from P to the plane. Now, the first method here that I'm going to show is, you want shortest distance? Can I find the foot of the perpendicular? So again, this is the plane, this is the point. I want to find the shortest distance. I drop the perpendicular, I get a foot, which we have done earlier. Finding foot of perpendicular, remember? Yes? Just find foot of the perpendicular, which we have found in example 7. Then find distance P, F, and we're done. Yes? So, let's do the simple calculations. This is actually OF minus OP, correct? Which is OF is 1.6 for 0.8 minus OP, which is 0 for 0. And I get 1.6, 0, 0.8. Do the calculation, you will realize that it's square root 3.2. The question just say find shortest distance. They didn't say exact. You could have used the GC to evaluate this, or you could have left it like that. I am fine. Alright? If they say exact, then you have to leave it like that. Okay, that's an easy first method. But could we have used another method? Yes, could we have used another method? Remember, there are 3 ways to find distances. 1 is endpoints. 2 is using dot product. What do we mean by dot product? Here, I'm going to use dot product, projection. Now, let us take a look at this equation of the plane r dot 201 equals to 4. The idea of projection works like this. I can use any point A on the plane. Any point. Let's assume, can you name me one point that lies on the plane? Can it be 2, 0, 0? Correct? It can be 2, 0 as long as it satisfies the equation of the plane. I sub 2, 0, 0, 0 in. I'm good. So A can be 2, 0, 0. A is just any point on the plane, 2, 0, 0. Yes? Now, the fast way of finding the projection, or sorry, the shortest distance between P and the plane, which is this distance, essentially PF, is to project PA onto the normal vector. And I am only interested in the length of projection, so I just put a mod sign. So it is this formula here, PA dot n hat. I suggest you don't memorize the formula. There's nothing to memorize. If you can draw the diagram well, then you know where is your if you can draw the diagram well, you know where is the normal vector here, and you know you can find PA. Don't memorize this formula, please. Alright, so let's put the numbers in. PA you can find, sorry, yeah, PA is here, 2 minus 4, 0, dot n hat, which is 1 over root 5, 201. That's it. And we can easily do the dot product. Blah, blah, blah. You get 4 over root 5. Now, this one was actually your square root 3.2 earlier. It just doesn't matter. It's whichever way. So, there are only 2 methods here. Remember earlier we said there are 3 methods of finding any distance. But in order to find shortest distance between a point and a plane, actually there are only two methods. One, find foot of the perpendicular first, coordinates, then you join these two up and we are done. Two, I project. Find a point on the plane, it can be 2, 0, 0, whatever, then find PA, project onto N. If you want to find AP, is it okay? Can I write this? Will I still get the length of projection, which is the length PF? You think? Yes, it's absolutely fine. Whichever direction, because all I'm interested is length. You must be very clear. Alright? It is fine. Okay? Now, in particular, I do want to raise this special case here. What if sometimes the question asks, find the shortest distance between the origin and the plane? What is special about the origin? It's just another point. But I want you to pay very close attention here. Okay? If I want to find shortest distance between origin, let's consider this equation of the plane. In general, we must be comfortable with in general. N is some vector, P is some number. Okay? Now, how do we find shortest distance between O and the plane? I need to find a point A, right? So actually it's OA dot N hat, right? Agree? OA dot N hat. Now, OA dot N hat. N hat is N over magnitude of N, of course. Now, what is OA dot N? Because A clearly lies on the plane, OA dot N, you substitute this in, must definitely be equals to P. I repeat one more time, because A lies on the plane, OA dot N must be P. So this one must be P. So in the end, it's P modulus divided by magnitude of N. So the shortest distance, I give you an example. That means now I give you an example. Find the shortest distance between origin and the plane r dot 201 equals to 4. Now using this idea, it will just be 4 over root 5. Done. Because it is mod P over magnitude of N. Get it? Yes? What if the equation is not this, it is minus 3. Then the shortest distance between this plane, origin and this is 3 over root 5. Done. Get it? So if your n happen to be a unit vector, look here, if n happen to be a unit vector, then it's even simpler. Because your n mod n is 1, so it will just be mod p. Yes, this is a special case I want to raise to your attention. Actually, there is not much calculation to be done. It's just by observation. If I give you another one, let's say example. Let me use another example. That means I don't want this one. Maybe it is 1 over root 2, 0 minus 1 over root 2 equals to minus 5. What is the shortest distance between O origin, alright, and this plane? Now let us observe that this normal vector here, 1 over root 2, this one, this is a unit vector. So once I observe is a unit vector, it's actually 5 over 1, which is actually 5. So the shortest distance is just 5. By observation. Done. So this is the point that I'm trying to make here. If n happen to be a unit vector, then it will just be the shortest distance will just be a mod p. Got it? Yes? Okay. So now is an example. I think I used this example earlier. So it will just be 4 over root 2 square plus 1 square equals to 4 over root 5. Done. Okay, now let's take a look at shortest distance between two parallel planes. Distance between two parallel planes. Again, it must be parallel. If two planes are not parallel, that means like this, then we don't talk about distance between the two planes anymore because they intersect in the line. Correct? Then there's no distance to talk about. Which distance are we talking about? Are we talking about we are two planes. This distance or this distance or this distance. There's no ending. As long as they intersect, there's no distance to talk about. Yes? So parallel planes. Again, we reduce the problem. The shortest distance between two parallel planes is the shortest distance between B, any random point, any point on pi 2, and the plane pi 1. So this is the most important. As long as you remember this, actually, I'm without a job. Actually, you can do it on your own. It's actually quite simple. Yes? But never mind, to earn my salary, I decide to go through example 12. Two parallel planes here, this one and this one. Yes. I have this equation and I want to find the shortest distance. First, we observe that this is the plane, this is pi 1, this is pi 2. So I first find a distance, a point A, which lies on pi 1. Here, this is pi 1. A is 0, 0, 27. Yes, because look here, 0, 0, 27 satisfies equation pi 1. So 0, 0, 27 here. B, I can put 0, 0, minus 4.5. Are there a lot of points who can satisfy this equation of pi 2? Of course. Similarly, are there a lot? Yes, there are a lot, but I randomly pick 2. Doesn't really matter. These two are not unique. So I say A and B lie on pi 1 and pi 2. How do we find shortest distance between B and pi 1? All I need to do is to take AB. Alright, AB essentially is OB minus OA. I minus them out. OB minus OA. I will get this 0, 0, minus 31.5. Then I project it onto the normal vector. Why does projection work here? Because look, AB is like that. I know the direction N. I know the shortest distance here, BF, must be parallel to the normal vector. So I take AB, project onto N, job done. Is it very difficult? I don't think so. If you know your projection idea well, then it's not difficult. So all I need to do is take AB, which is here, project onto N, which is the formula. I rather write the formula. Mod AB dot the unit vector of N. Agree? Do we all agree with that? Then we just do this. 0, 0, minus 31.5 dot 1/3 2 minus 2. You do the math, you will get a 10.5. Okay, done. That's that between two parallel planes.